Okay, let's start the session. In last session, we discussed about key column and name column, right? So mainly the key column is one for querying purpose and the name column is for display purpose. Now, in today's session, we're going to cover a couple of concepts like we'll cover one parent-child hierarchy, and then we will cover different types of dimension creations. And then if you have time, then we will look into the processing options. Okay. So for this parent-child hierarchy, the key column and the name column concepts are very important. That's why I covered it in last session. Okay. Let's see. What is parent-child hierarchy? In time dimension, we have created some hierarchies by dragging and dropping the attributes from attributes pane to hierarchy pane, right? You can give any name, whatever the name you want to give, like calendar hierarchy or something like that. You can just click on it or right click and rename and change the hierarchy. Calendar, I don't know the spelling, calendar hierarchy. So this is how you can rename it. Just click on it once and then click on it for second time. It will give you this option of changing the hierarchy names. This is fine. This is normal hierarchies. What is parent-child hierarchy? Parent-child hierarchy will come into picture when you have some hierarchical nature of data in the same table referring to the same column. Let's say, for example, to explain that one in a better way, I need to take Excel. So let me take the Excel sheet first. Employee ID, name, manager ID. Employee ID 1, Rupesh, 2, Lokesh, 3, Vinay, 0. That means, or null, let's say null. This table has self-reference. Self-reference in the sense, one column in the table is referring to the primary key of the same table. The foreign key reference, normally how the foreign key reference will be. If this is your primary key table and this is your foreign key table, you will have reference like this, right? Foreign key to the primary key table column. Here, this is your primary key column and this is your foreign key column. You will have reference like this, self-join or self-reference. So when you have data like this, then while defining the dimension or when creating the dimension, you can define parent-child hierarchy. The hierarchy will be like, first it will take the null item, that is Vinay. Vinay is the top guy. Under him, Vinay ID is 3 and hence it will go to the manager ID 3. This guy is manager for Lokesh. So under him it will be Lokesh. And it will take this guy's ID, that is 2, and manager ID is 2 for Rupesh. So under this guy, it's Rupesh. So this is how the hierarchy follows. Parent-child hierarchy when both the primary key column and the foreign key column exist in the same table, that is self-referring, then in that case, we can go for parent-child hierarchy. Now, let's see how to define parent-child hierarchy and how can you identify whether it has a parent-child hierarchy and so on. In the AdventureWorks database, what we have, there is one table which is having parent-child hierarchy kind of data. The table name is employee, dim employee. Let me take the table first. Dim employee, I've taken it. And you can see this guy has self-reference. And if I double click on that, you can see parent employee ID is referring to employee ID. Parent employee ID is nothing but manager ID here. This guy is having reference to primary key column of the same table. So when you have data like this, in this case, you can go for parent-child hierarchies. Now let's see how to design it. How to design parent-child hierarchies. So to design parent-child hierarchies, there is nothing much to do. What you have to do is simply define the dimension. Right click, new dimension, use existing table, and here you have to select dim employee. The key column is selected and the name column is also the same. Click on next. you can see the parent employee key is by default selected. Why? Because that is the self-referring one. So if you uncheck this, the parent child hierarchy will not be created. If you check this, let me show you an example. I'm leaving it as is. Click on next. I'm not taking any other attribute. You can see this is self-referring one, and you can see the icon is hierarchy icon. It is not attribute icon. Attribute icon is 6 square boxes like this, whereas hierarchy icon is this one. Okay. So that means when you define the hierarchy in the when you define the relationship in the data source view, while designing the dimension, it automatically takes the primary key, parent child hierarchy. Nothing else to do. You just need to check that. So if I process it, let me process this particular dimension alone. So process is successful, and you can see the attribute is processed, all attribute and key attribute, and hierarchy is also completed. Let me show you the data, how the data looks. This is the parent employee key, the one which we are calling it as hierarchy. So top guy is ID is 11112. Under that he has so many employees. Under this guy, this is the list of employees. Under this guy, this is the list of employees. Under this guy, this is the list of employees. So this is how the hierarchy will be automatically created. Parent-child hierarchy will be automatically created when we have the self-reference in the data source view. So this is why I used to say data source view is very important while designing. Make sure that the data source view is designed in the best way. Now this is done. Parent-child hierarchy is created, but you can see this is not the best way of doing parent-child hierarchy, right? You can see there are IDs. IDs are self-referring, but you need to show employees. That is more meaningful than providing the IDs instead of employee IDs. Let's see what are all the changes we can do for the same, and how to make it more beautiful. I'm deleting it. Let me create the dimension again. So click on next. I'm selecting the employee again. Click on next. Here I'm selecting all the columns, and I'm not selecting this parent employee key. Click on next. You can see that hierarchy is not gonna be created. When there is any foreign key reference, self-reference like this, then if you select that attribute or that column, by default it will create hierarchy. Okay. Now that hierarchy is not created. So this is as simple as this. Creating or not creating, it's in your hands. If you select that, it will be directly created. If you drag and drop this one now, here, this will be taken as an attribute, not the hierarchy. Keep in mind, this is where you have to be very careful. So while adding the dimension itself, you have to check that if you want to define parent-child hierarchy. Okay. Now, before going further, I want to make some adjustments, like the first name, last name, and middle name are 3 different columns here. I don't want to have 3 different columns attributes for that, so I want to make it one. What I can do? The best way of doing that one is adding a calculated column. So here I am giving the name as full name, first name plus space, middle name plus I'm giving some space, last name. So these 3 combinedly will form a new calculated column called full name. Let me execute and see whether the data is coming correctly or not. So the first name is Guy, the middle name is R, and last name is Gilbert. Guy R Gilbert. It is coming fine, but unfortunately this is coming as blank, the third one. Robert Tamburello, and middle name is space, that is null. That is why it is coming as blank. Why it is coming as blank means, if you go to this function, this calculate measure, this has some value and this has some value, but this is null. String plus null is null in SQL Server. So that is why it is coming as blank. So what I'm gonna do here is I'm checking if it is null, then convert it into blank. This is fine. Now let me execute and see whether the data is coming correctly or not. So this is perfect now. If it is null, it is converting it to blank and then concatenating the value to the first name and the last name. So this is perfect. Now let me create the dimension again with the new data. So I'm selecting the table dim employee. I'm taking parent employee key, and I'm not taking first name plus last name plus middle name. To make it more easy to understand and more meaningful, I'm taking only full name. I don't want any other attribute here. So this is key column, this is hierarchy, parent-child hierarchy, and this is the full name. Let me show how the data comes. So let me process the cube now. So not cube, I'm processing only dimension. So this is successful. Let me go and browse the data. This hierarchy, it is still showing the keys. Why? Because the key column is the same, and the full name, it is showing the middle name plus first name plus last name. So this is perfect. Up to here it is perfect. Now let's do some changes. Okay, first parent employee key. This is not meaningful one. So manager employee hierarchy. This name is bit better, right, than parent employee key. So I renamed it. What is the next step to do? First, go to the key column, go to the properties, and make sure that the key column is employee ID. Perfect. The name column, instead of employee key, I want to show full name. So if I process now, you can see whenever I drag employee key, it will display employee names. We discussed about this a lot in last session, right? Oops, that is hidden. So let me change it to visibility. And if you go to the properties, and you can see the attribute hierarchy visibility property here, the one that I am highlighting is set to false. That's why you are not able to see that particular attribute here. Okay. So this attribute hierarchy visible property is very important. If you set it to false, that attribute will not be shown to the end user. So make sure that is set to true if you want to use this particular attribute in your analysis. If you don't want to use this, then you can set it to false. Okay. Now in this case, I want to see whether the data is coming fine or not. So I'm setting it to true. So process successfully. Now let me reconnect. I have employee key. When I select that, it is showing names instead of keys. The first thing is set. Employee manager hierarchy. This is also automatically set. Why? Because this particular column is referring to employee key. Okay, and getting the data of employee key, whatever the name column is present, that will be showing in the employee key file. If you see here, everything is showing in the hierarchy. So this is how you can define parent-child hierarchy for any table which is having self-reference or foreign key reference. Okay. So what are the steps you need to do? First thing, you have to make sure that particular thing is selected. The particular foreign key column of the table is selected in the list of attributes that you are dragging. And next thing what you have to do is you have to make sure that the employee key column or the primary key column has a valid name column to display. If you set it to employee key again, then it will show in keys. That will not make any sense for us. So if you want to show the names, believe me, I spent some 1 week or so to achieve this particular point. I don't know about this name column concept that time when I started my career. So it was a big achievement when I finished this task. Okay. So I'm explaining you. So be careful and take it straight into your mind. You have to make the name column as the name what you want to show for this particular hierarchy. How this acts is, how this functions is, this guy will take this ID and joins with this employee key and then shows the name column of the employee. The name column of the employee key is set to full name. So this is how you can configure parent-child hierarchies in the dimension table. Now, let's say while creating the dimension, I have not selected it. So then how can I do that? While creating the dimensions, by mistake, I have not checked it. In other words, let me explain that by creating the dimension, a fresh dimension. So while creating the dimension, I selected the primary key column here, the table, and here I'm unchecking it. Okay, by mistake I have done that. Okay, let's assume that. And I created the dimension. The dimension creation is finished and I use this dimension in many other places. Now, how to edit that? The first step is make sure that this guy is having proper name column. This is set. And next thing, drag and drop the foreign key column here. Okay. Rename it as per your requirement. Manager employee hierarchy. Now the major important property we're going to set, that is usage. Usage of this particular attribute is not regular. It will be parent. So if we set it to parent, automatically you can see it has become hierarchy. So now I set it to parent. This is foreign key. What is the primary key? Obviously the key column of the particular dimension. The key column of this particular dimension is the employee key. So remember, there are three types of usages. One is key, that is the key column of this particular dimension, and another one is parent, that is parent-child hierarchy attribute, that is foreign key column of the same table, and the third one is regular, that means it's just a plain column of the dimension table. Now I set this one to parent, that's it. If I process this should process successfully, and I should be able to see the hierarchy of a manager and employee in a proper way. Let me check that, confirm that. So if you see here, manager and employee hierarchy, the same hierarchy is showing here. So this is how, if you miss to add the parent-child hierarchy at the time of creating dimension, you can modify it. You can add it, or you can update the dimension with the parent-child hierarchy just by selecting that particular attribute and then changing the usage to parent. So this is complete picture about parent-child hierarchies. And these parent-child hierarchies are very, very, very useful one. You cannot achieve this straight away. Normally in SQL Server, you have to use some common table expressions which will be covered as part of advanced concepts. So you have to use common table expressions to achieve this kind of hierarchy. Okay, self-referring hierarchy. That is very performance related, performance issues will come into picture if you use it. But this is pretty easy way of doing parent-child hierarchy in the dimension. So now we are good with parent-child hierarchies, and we are good with how to give attribute relationships and so on. And now let's go to the next concept, that is, when I started explaining about the dimensions, I told you we will discuss about the remaining three types. We always considered about use an existing table option, right? Now in this session we are going to cover the remaining three types of dimension creation method. Okay, let's start with the second one. Why? Because the first one is pretty familiar for you guys. You might have created some hundreds of dimensions by this time. So let's go with the second one. So generate a timetable in the data source. What is the data source for us? For us in this example, the data source is the one what we created here, that is AdventureWorks DW. So you can see the description here. Create a new time dimension table in the underlying data source. Underlying data source means whatever the database that I selected in this particular data source, that is the underlying data source. The dimension will contain data for the date range, attributes, blah, blah, blah. So in short, what it will do is, if you select this option, it will create a table in the database, a new table in the database, and it will create a dimension by referring to the table. So when we need this option, whenever we don't have timetable in our database. As I told you many times, without timetable, without time dimension, cube is nothing. So most of the calculations people, they'll go with time. Like this year sales to last year sales, this quarter sales to last quarter sales, this week sales to last week sales, or same week last year. So all the calculations, most of the calculations are purely dependent on time dimension. So if you don't have time dimension defined, then you need one. But fortunately, in this Adventure Works database, if you see, there is a timetable created already. So this is already created with so many columns. All kinds of combinations are present in this particular timetable. Let's say this timetable is not provided, then there are two options. One is manually you create that, or go with this option, generate a timetable in the data source. Why they have provided a direct option like data, creating the data table and in the data timetable in the data source and all. Why? Because the data that will be present in this table is fixed one. Whether you create or I create, for this particular date, the day number of the week will be 1, English day name of the week will be Sunday, and the same data will be present even if you created the table or I created the table. This is universal truth. The timetable will remain the same. So that is why the option generate a timetable in the data source, and you will come to know, you will clearly get the concepts when we go further in the same. So let me select next. Here it is asking from when to when you want to create the calendar. Here in this case, these guys has created from 7 means it's July, right? July 1st, 2007 to August 31st, 2004. So here, what I am gonna do here is, I want to do it from 2000 to 2012. January 1st, 2000 to 2012, that is 12 to 13 years of data. Now, the next thing, first day of the week, how you are gonna count? Few guys will count it from Sunday. Few guys will count it from Monday. Few guys will count it from Tuesday. But the default one, universally used one is Sunday. So let's go with the same one. Why this first day of the week is important? If you see here, one of the column is dependent on that particular data. That's why it is important. Yeah, day number of the week. If it is Sunday, it will be 1. If it is Monday, it will be 2, 3, 4. So to capture this information, why this information is important. If you want to see the sales on Sunday, then you need this column, right? These two columns are required. So for that information, this particular thing is required. So this is the start date of the calendar that I am wishing to have, and this is the end date. And what are all the time periods you want? I want year-wise, all the time periods, half-year-wise, quarter-wise, tri-semester-wise, month-wise, 10 days-wise, week-wise, and everything. And what is the time, whether it's a France, Japanese, or Germany, or English, United States. I'll go with United States. Click on next. Now, here, regular calendar or physical calendar. Physical calendar will start in a different, right? It's not like January to December. Regular calendar is January to December, whereas physical calendar starts from somewhere in March or April. For some companies, it starts from October. For some companies, it starts from July. So if you wish to have physical calendar, you can go with this option and change it. What is the first month? Let's say this is the first month that it is going to start. So like that. If you want a physical calendar, you can have this. And reporting or marketing calendar, it is one other calendar type, and in the same way manufacturing calendar. Having regular is more than enough, and if you wish to have physical calendar, check this one too. Click on next. You can see all the attributes. Date is the key column. Year, half year, quarter, tri-semester, month, 10 days, week, day of year, day of half year, everything will be included. You can see physical year, physical half year, all the attributes. That means all these columns must be present. And it also creating the default hierarchies, the natural hierarchies that is possible with the data that is present in this particular table. If I create finish, done, you can see all the attributes are created and all the different hierarchies are created. Now, what this red mark, the source is not specified. That means it created the skeleton. It created the skeleton for the time dimension. And if you see, the time table will not be created here. Time underscore 1 or some name will be given. Some name will be given. It is not available in the underlying data source, that is our AdventureWorks DW. So if you see here, the table is not generated. What it has done, the SSRS part, SSAS part has done is it just created the skeleton. What are all the attributes I'm expecting to have, and what are all the different hierarchies as per the definition I have given while creating the dimension. So if you see here, click here to generate the data source view. I have to click this to create the table in the underlying data source. Okay. Okay, fine. Next, 1 second. Use the existing data source view. If you want to create the timetable in the same existing data source view, click on next. Here it is asking whether I want to create primary keys in the underlying database table, or whether I want to create indexes, or whether I want to create a referential integrity, preserve data and regeneration, and all those stuff. Everything let it check. Here this is the information for you. And what is the separator you want to you want the server to use, underscore. What is the prefix you want to use? For primary keys it is PK, for foreign key it is FK, name it is NAME, attribute name suffix, something like that. So all this information, and if you click on finish, you can see it is trying to create the table in the underlying data source. So the underlying data source is nothing but our AdventureWorks. Let's see whether it will create it successfully or not. It is still processing, saving changes, committing changes to the subject database is going on. So it made, if you see here in the bottom, generation completed successfully. What it is generated? Here you can see time underscore 1 table is created. And in the data source view, the same table is created, here, and all the primary keys, blah, blah, blah will be created by default. You can see primary key and everything. Now the challenge is, let's see whether the table is created in the database or not. In the database, the same table is created with all the columns that we mentioned there. Right? Everything is. So why we need this? This option is the most beautiful option if you don't have your timetable in the database. Let's assume you don't have your dim timetable. Select star from. Let's say if you have not designed this table, then if you take the help of SSAS, it generated a beautiful timetable for us in fraction of seconds. And if you see the data is started from January 1st, 2002, the time 31st December 2012, whatever we have defined. So this is the easiest way of creating the timetable if you don't have your timetable as part of your data warehouse design. So this SSAS will help us in creating the timetable in the database as well as creating the dimension in the cube, right? It has done so many things. One is it created the table in the database. This is the first step. It added that particular table to your data source view, and it related to the it added to the data source view, and then it created the dimension, and then it added the attributes, it defined the hierarchies too. Not only this, okay, it will also do the attribute relationships properly. You can see fantastically it has designed all the attribute relationships. Okay, if you see here, all the attribute relationships are defined based on the hierarchies whatever we define. Now, why I have kept this till this point? Why? Because first of all, you need to know what is dimension clearly. That's why I have not explained this particular option till then. So now you are familiar with the keys and key column, name column, and attribute relationships, and how to create dimensions and so on. So now I have taken opportunity to explain this part, and hope you understood the concept. Now let's go to the third one. Generate a timetable on the server. Few cases, the clients will not give you permission to create the tables on the database. like this. Now we have created a table. The SSIS server has designed a table as per the requirements whatever we have defined. So drop table. Most of the clients, they won't give access for you to create the tables and so on. Okay. So in that case, we cannot go for that option, right? Whatever we use now. Why? Because that one will create problems. It will say you are not, clients will say you are not allowed to create any table, but you have created a table with the name time_1. This is not suggestible. So if we don't have permissions to create such tables like timetable and so on, then what is the next option we can go for? The clients won't provide timetable for us to create time dimension, and they won't allow us to create timetable in the database. Then the third option, the best option we have is generate a timetable on the server. So this guy is pretty different. In the same way, you have to select. Let me go with 2009 to 2012, and again in the same way I have to select. It is similar to the second option what we have seen, but the only difference is the second option creates a table, physical table in the database, whereas this one, it won't create any table in the database. It directly deals with, I don't want physical now, it directly creates a table on the server. If I click on finish, you can see the attributes are added, the hierarchies are created, relationships are given, and if you see this, this icons means this table is a server table. If I process it, this one will be processed successfully without any problem. Why? Because the dimension is not dependent on the database table. The data is coming from the server. So everything is processed and you can browse and see the data. If you click on browser, you can see hierarchy is selected. For this hierarchy, you can see the data the most beautiful way. So the three different options, whatever we discussed till now, are number one, it uses the existing table. Number two, this one creates a timetable in the database and then make use of that to create the dimension here. And the third one, this generates a timetable on the server and uses the same thing to create the time dimension here. This one, if you see in the data source view, you will not find any table called time here, whatever that is created by this dimension. Why? Because it is directly getting the data from server. It creates the table in the server side and it will make use of the same server table. So it depends on your requirement. If the table is already created by the clients, then you can use the first option, use existing table to create a time dimension. And if the table is not created by the users and if clients and if they ask us to create the table on our own, why? Because the data is fixed one, even they create or I create, it will remain the same, the data in the calendar table or time table. So in that case, we can go with this option. And if user says, I have not created it and I don't allow you to create the same, make some other option, maintain it in cache or something. So in that case, you can use this option, generate a timetable on the server. So these are the three different options. What is the fourth option? Generate a non-time table in the data source. This is similar to the second one, the second option. The only difference is the second option will create only timetable. Here it can create anything. For example, if you want to create a table for customer and if you don't know the columns, what are all the default columns? So Microsoft has done a fantastic job by collecting them, what are the minimum columns or the most frequently used columns for each template. If you are defining a product template and if you don't know what are all the columns that are required, if you are defining a sales reason table and if you don't know what are all the columns required, then in that case, you can select this template, click on next. This one will help you what are all the columns that are required. If you click on finish, it will give you what are all the columns that are required for creating this customer table. You can see for a customer, these following things are required: address, birth date, city, commute distance sort, company, country, last name, status, marriage status, middle name for employee, email address, education, blah, 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 lot of information. And if you click on generate a table in the database, what it will do is it will create the template. It won't fill the data. Why? Because Time is universal. Wherever, whoever fills the data, it remains the same. Whereas customer, it is not the same. So let me execute the select star from customer query and see what it has done. So if you see here, it has created a template, and based on that you can insert your information. You can insert the data. If you don't know, if you are not getting the thought like what are all the columns that are required for a particular template, in that case you can make use of the option generate a non-time table in the data source. Let's say I don't know what needs to be added for source currency template. I don't know what the source currency also. So here you can see these are all the columns that are required. So click on finish. It will have all the columns that are required, that is 4. If you generate a table, it will generate a table in the database, underlying database, so that you can make use of the table. So this is the advantage of the option generate a non-time table in the data source. And these are the 4 different options that are available for creating the dimensions. So if I explain this one, if I have explained this one earlier when we started discussing about use an existing table, you would have confused. Why? Because this is generally a new concept, right? I mean, you are new to this, and at the same time, if you don't know what is dimension, in and out about the dimension, then you will get confused. That's why I kept it to the end, and now hope you understood the concepts. Okay, fine. We are done with parent-child hierarchy, and we have done with the different options that are available while creating the dimension. Now let's see the different types of processing techniques. Okay, before signing off for the day. Processing, you know very well. Processing, what it will do, it will pull the data from your relational database and push it into your analysis services or relational database. Depends on your storage mode, whether it's a whole app or roll app or mole app. Based on that, it will manipulate the data and it will store the aggregated information either in relational database or in analysis service database or in both. Any option is there. If it is whole app, then it will store the data in relational as well as in analysis. Whereas if it is whole app, the data will be stored in analysis service server. Whereas if it is roll app, the data will be stored in relational database server. Now, we're just simply right click and clicking on process, and we're giving the information. It is throwing some error. Why? Because I've defined this, but source tables are not yet defined. So let me delete this stuff, as we are not much worried about these tables now. So let me click on process. First it is deploying, and then it will ask you for process. Here what we are doing, we are just simply clicking on run to execute the process. Here one important thing is there to know. I mean, you have to be aware of this option, that is process options. You may ask, what is there in process options? It is selected by default. It is selected by default, but there are different options you can select. So when you right click on solution, you are getting 3 options. One is process default, process full, and unprocessed. When you right click on solution, right here I'm right clicking, and when I click on process, I'm getting these 3 options. When I right click on dimension, I'm getting different options, right? And third thing, when I right click on cubes or partitions, better to say, when I try to process this, I'll be getting entirely different options, even more. Okay, so let's see each and every one now, or at least let's cover 50% of the processing options today, and we will cover the remaining options in tomorrow's session. Okay, first let's cover this. If I click on process, I can see 3 options. One is process default, one is process full, and third one is unprocessed. So what is a process default? Process default, it will check what is the existing status of the solution, whether it is already processed, or that if it is processed, when it is processed, and what is the new additions to this cube, and what is the new deletions from the cube. It will check for the status of the existing cube, and it will take the best option. What is the best suitable one? It will take that option. Okay, that is process default. So obviously the best one, it will take less time, right? It will take the best position of the cube and it will continue from there. Let's say I have 50 measure groups, which is not possible. One very rare cases people will go for 50 measure groups. Let's say I have 10 measure groups, 5 are already processed and only 5 are newly added. So if I select process default, it will make sure the 5 will not be affected and the remaining 5 will be processed, or it will take the best way to process the cube and make it a successful one or ready to browse one. Okay, that is process default option. If I select process full, what it will do is it will delete the existing cube. Let's say I have data. This is my analysis services. This is my cube, and I added some new things to the solution here. Then if I select process default, it will take the best way to pull the data from here to here. If I select process full, it will erase this part first. It will remove all the data from your analysis services and a fresh copy will be done. That means it is processing from scratch. So process full is always time taking one. Why? Because it will erase the complete solution erase the complete data in analysis services and it will start fresh. The third option is unprocess. If you select here, you can see the third option, unprocess. Unprocess is nothing but it will not process anything. It will just simply remove your analysis services data, the data that is present in your cube. That means you cannot browse, you cannot access anything. Let me show you an example. I'm processing the cube solution with the default. It is successful. See, it has taken very less time. Why? Because it has taken the best way, based on the current status. If I go to the browser, you can see I can browse the data. Sales amount and calendar year. So I can able to see the data. Now, let me go to the process again. Let me do process default again. This is done and you can see none of the partition is processed. Nothing is done. If I select process full, first what it will do, it will delete the existing one and then process the full data. That's why it will show the processing of the partition. Right? This is the difference. Process default will take the best way, whereas process full will delete the complete one and freshly processed it. Now I am doing unprocess. Unprocess is nothing but deleting. That's it. It will simply delete it. Now if I reconnect it here, the cube cannot be browsed. Verify that the cube has been deployed and processed. Why? Because I have unprocessed it. I have deleted it. So nothing is present in the cube now. So these are the three different options that are available for us for processing the cube at solution level. Let me process it. Let me go for process full. So done. Now let me go to the dimensions part and click on process. You can see process default is there, just like process default what we have discussed. It will take the best possible way of processing this particular dimension. And process full, it's the same way. It will delete the existing dimension data and process it from scratch. And unprocess is also the same way. It will unprocess the dimension. That means it will deallocate the data, that is deallocate the memory and deallocate the data or delete the data that is copied to the analysis services server. Now let's see the remaining options here. Process data, process index and process update. Here very interesting one is process data and process index. When you click on process full, what will happen is it will pull the data. That means it reads the data. That is the first step. So that is equal to process data. The next step is as part of process full. Let me take the pen here. If you take process full, what it will do is first from a SQL server, it will read the data. That is one step. Next step is it will create indexes on top of this, the data that is read. So process full is equal to process data plus process index. So if it is equal to, then why we have two different options? Why we need two? As long as data is processed here, so the process data, it will read the data and then create the indexes. So process full is equal to process data plus process index. Then why we need these two options rather than having one? As long as you are reading the data, you need to have the connection with your database, right? You need to have connection with your database. Once the data is read, then you don't need to have connection. That means whenever you are doing process data, you need to have this connection with your database. Why? Because it is reading data. It is writing select statements and reading data. Once the data is read, then only index creation. In that case, you don't need to have this connection at all. That is one advantage if you go for process data and process index. And it is also proved that process data plus process index, if you apply these two, it takes less time than process full. Process full takes more time. The time that is going to take for process full is greater than process data time plus process index time. So people prefer to process the complete data first and then apply the indexes on the data that is processed. And also remember, if you finish only process data, you cannot able to browse the cube. You have to finish these two. Process data if you have done, then you need to do process index. So this is about the process full and process data and process index processing options. The process update is pretty tricky one. Why? Because if I add a new dimension, let's say I'm adding a new dimension, let me add a product. So let me select everything, finish. And if I right click on this and click on process, you can see the process full is there, process default is there, process data is there, but no other option is available. So when you add a new dimension, then you have to go for process full, no other option, no other go. You have to go for process full. When the data, when the dimension is already processed once, let's say I'm processing this dimension, if the data is at least processed once, then you can see the remaining options like process index, process data, process update mainly. You can see the process update is come into picture. So the process update will come into picture only once the data is, only at least once the dimension is processed. That means this is your analysis service, sorry, SQL server, this is your analysis services. At least if you processed once, the data will be pushed into here. Now the process update will come into picture. The process update, what it will do is, it will take each and every record that is present here. Each and every record. It will take it, it will read, check here whether it is present or deleted. If it is deleted, then this will be deleted. Next it will take a new record. It will check whether it is deleted or modified. If it is modified, this record will be updated as per the source, whatever it is modified. Like that, it will check for all the records and also it will check for newly added records here. So this is the most time taking one. Why? Because it has to go through all the records here and compare with all the records here, and then it has to go through newly added records also. So this is the most time taking one that is available in the SSIS processing options of our dimensions. Now this is the different options. We discussed about the options available for dimensions and the cube. The next one, sorry, dimensions and the complete solution. The next one, let's go for processing of the measure groups or cubes, whatever you call it as, both are one and the same. If you see, you will find almost all similar. Default you are very well aware, full you are very well aware, data is very well aware, structure is the new one, unprocessed is the same old one, index is the same one, and incremental is the new one. Incremental is newly added in the SQL Server 2008, whereas process structure is the other one. Process incremental, you have to configure, like what is the measure group table, what is the source table, and so on. So what it will do is it will check what is the newly added data. If you see here, select a measure group and partition to update, then specify whether the source of the updated data is a table or a query. If you update which fact table or which measure group you want to update, and if you specify the source, what it will do is it will check, it will find out the newly added data, and it will update the same. That is incremental job. Okay, newly added records will pull and then increment incrementally, it will be added to the existing measure group. The process structure is one of my favorite one, the best one whenever you are developing, whenever you are working on the project, or whenever you are fixing the bugs. This process structure is the most beautiful option to use. So what process structure will do? Let me execute this and show you. When you click on process structure, what it will do is it will process the dimensions. It will not do anything. It will just simply process the dimensions, and it will say that measure groups are processed. That's it. It won't process in real. In real, the measure groups, you can see the sales amount is showing as blank. In real, it won't process. What it will do is it will process only dimensions, and it will mark the measure groups as processed. It is a fake one. It is a fake call. It is a fake information. In real, it will not be processed. In real, what will happen is only the dimensions will be processed and fact tables will not be processed. Why this is a fantastic option when it is not processing the measure groups? Let's assume you have 5 to 10 dimensions and 2 to 3 measure groups. Okay, let me add one more measure group to make it more meaningful. I'm adding one more measure group, then let's say product. Okay, now I fixed an issue. Let me add it. Oops. So let me add a product, and let me add a product dimension. Now, how many dimensions I have? I have 3 dimensions and 2 measure groups. Let's say I fixed an issue in fact internet sales or product, any one measure group. You can see 2 partitions here, right? Let's say I fixed some issue in one of these measure group and I want to test it. And assume I fixed issue in this particular one, and this is I have not done any change in this one. And assume this guy is having 50 crore of records and this guy is also having 50 crore of records. Okay. First, what I have to do? I have to test whether the fix is done properly or not, right? I have to test that. Once it is tested successfully, then I can process this. Or else while testing, if I come to know this fix is not closed, this fix is not completed, then no meaning in processing this. Then what is the next step? Again, I have to go here and fix it and again test it, right? So what I feel here is processing these 50 crore of records will take 2 to 3 hours for me, which is waste of my time. So in these cases, whenever you want to test or whenever you want to process only one particular set of measure group or 2 sets of measure groups, it depends on the requirements, then in that case, first do process structure. So if you do process structure, it will process the dimensions and it will mark the measures as processed and it will make the cube ready to browse. This is the fantastic option, ready to browse. But you can see nothing, no data will be available here. You can drag and drop any measure group and you can see data is not available. Now go to the partition which you have fixed. Let's say this one I made some fix. If I process this one alone, that is enough and I can browse the cube. Generally, this is not the case. In real, you have to process all the measure groups to browse the cube. But using this process structure, I can process only one partition and see the data. You can see the data is coming. If I feel this is fixed completely, the issue is fixed, then simply go and process the next partition. That is more than enough. The cube will be completed. You don't need to process the complete cube again. If you see here, the weight is also coming into picture. So this is the beautiful option that I was talking about. If you want to test it before going further, then do process structure and process the partition, whatever you feel that there is a fix you have done. I mean, whatever the partition for which you have done some fix. And if you feel that the data is coming correctly, then go to the next partition or the remaining partitions and process it. If the data is not coming correctly here, then what is your next step? Fix the issue first. Again process structure and again only process this partition, then check whether the fix is, until the fix is completed, fix is successfully closed. Once the fix is done, then process the remaining partitions. This one will save a lot of time. Instead of processing all the partitions to check at least one, the only fix you have done, you can simply process structure, which will make all the dimensions processed and mark the measures as processed, and you can process only the particular partition where the fix is done, so that this one will help you in reducing the overhead of processing all the measure groups to check the fix you have done. So that is why I love this process structure option. So this one is the most beautiful as far as I'm concerned. So if you see, the steps involved is, first, let me go to the cube, process full, process incremental, nothing is there, I think. I mean, complete cube is processed. So let me unprocess this. So this is completed. Now let me go to the browser and process it. Select process structure and click on finish. Now the dimensions will be processed, and you can see the dimensions are processed. These are completed, but no data is read. Generally it will show number of records that are read from the database. It will not show that. After doing this, go to the partition and process your appropriate partition which you want to process. That is it. So it will make the cube available to browse with only the data that is from that particular partition. This is not gone, I think. I have processed both the things. Okay, fine. So this is about the different processing options. You can practice it at home, and I mean, you try to find out what are all the differences if you take different options. Now, like, try to find out by applying process full once, and then go with process data and process index, how much time it is gonna be saved. Don't go with 40,000 or 60,000 records. You have to go for good amount of data, like 10 crores or 20 crores. For that, what you can do is you can insert some junk data into the same table. Select star from fact internet sales will give you very less data. So what you can do here is, you can create a dummy table with the same structure by removing the keys and all, constraints and keys. Then insert the data from here to there. That one will help you in analyzing the different processing options. So that's it for this session. We discussed about parent-child hierarchies and different processing options, and also different options for creating the cube, like by taking default time dimension and timetable in the database and timetable in the server, and different types of tables, templates in the database. So catch you in next session. Thank you.